Good morning, everybody. Hello, everybody, and a massive welcome to the iRODS Forum. My name is Marco, based in Munich. I'm the CEO of Do IT Now, and Terrell from iRODS, from the iRODS Consortium, and we are actually excited to host today this session for you because we believe we have here a critical and in current landscapes. The motto of today is actually to having a session about secure and compliant research for industries and academia. Um, Taron and we had an idea, and this idea actually came true. Why this forum? Why now? Well, in today's incredible complex technology world, the data are compliance, and not just only for you and us, is actually a fundamental pillar. So we actually came to the conclusion to organize such a meeting and dive with you into this architectural concept of iRODS, but having also experts using this and sharing their experience today. And I will also welcome Lazlo from maybe you can introduce yourself, Laszlo, and say shortly hello to the team here.
Yeah, sure. Good morning, everyone. I'm Lasse Westerhof. I'm from Utrecht University.
Right, thank you. And Nirav,
Hi, I'm Neera Merchant. I'm the director for the Data Science Institute and the PI for Cybers at University of Arizona in Tucson, Arizona in US.
pleasure to have you here on board. John,
Hi, folks. I'm John Constable. I work in the IT department of Wellcome Sanger Institute in Cambridge, UK.
right, thank you so much. And Terrell, last but not least.
Yes, hello. Thanks for hosting this, Marco. I'm Terrell Russell. I'm Executive Director for the iRODS Consortium, which is housed at the Renaissance Computing Institute at UNC Chapel Hill in North Carolina in the US.
Great. Good. Thank you so much, gentlemen. So these guys are diving a little bit deeper into the topics. So what can you expect today? We actually are doing some you will witness here practical strategies in a real world compliance solution. So compliance is a complex things. We're having different country-based solutions in that kind of area and requirements, what we have to fulfill in academia and in the industries. But we will talk about automated enforcement, audibility and actions, and the flexibility to meet up specific demand needs in this kind of environments. And of course, Terrell will give you an overview about the concept, which actually enables all those activities. Maybe we are switching to the next slide, please. And this is also, I need to introduce you. Right, so okay. Hosts are me and Terrell, and then we are diving into the challenges and the goals of today, of course, to introduce iRODS for compliance and hear the experts from real use case scenarios. Next slide, please. Okay, Terrell, this is your
Yes,
slide. Please explain us what iRODS can do in that world.
that's right. So I have two slides to do this rather than hours and hours, which is probably good. So I think most of the attendees, we looked at the list, are not familiar to us, which means that you guys are new to this set of ideas and maybe some of these words. So we will start very, very high level, and I'll let our expert panel go a little bit deeper when they need to about how they implement these things. So the 50,000 foot view is that iRODS is an open source piece of software. It's got almost 30 years of kind of thinking, and the bones of it have been around for a while. It is a C and C++ application. It is a data management software platform, and it allows people to take control of what their data is doing and where it lives and how many copies and who's talking to it, who's touching it, all those kind of things. It provides basically four sets of technology that kind of fit together. And so This is the integrated part of the integrated rule-oriented data system. So we virtualize storage, and this was very sexy and interesting kind of before cloud happened and made storage much easier for people. It originated in plasma physics when the research was generating data that did not fit on a single disk. And so the concept of grid storage started 25, 30 years ago. And so iRODS incorporates some of that original research and thinking into how it talks to different types of storage technologies, disk and flash and tape and object. And all of these things can be seen and touched and controlled within a single unified namespace. So iRODS is effectively a file system, but across disparate technologies at the same time. It also provides a metadata catalog where arbitrary user-defined or administrator-defined metadata can be associated with the things in the system. And that allows people to do interesting things at their domain-specific level to be able to attach metadata that matters to them to the data at the level that it matters to them. And all of this is available through an API and through lots of different libraries and technologies. But the core is that the metadata and the knowledge of where things live in a catalog, also known as a database. And then on top of those two things, we have a policy engine. This is a rules-based system that is all, it's not somebody else's system. This is the iRODS system. And it allows people to write rules and policy that enforce certain things around the system. So that's what the next slide will be about a little bit more, because that's the point of today's session. And then the last point here is that iRODS is open source and it is its own protocol. It does allow federation with other instances of itself. And so from a sovereignty perspective, that is interesting. You've got the ability to run this code yourself in your own computers at your own time and your own place. And that allows independent peers to federate and share and control their own policies across their organizations, which is becoming more and more interesting as some of the opinions about large hyperscalers are starting to shift a little bit. And obviously all those free credits have evaporated in the last couple of years. iRODS itself is just a piece of software, right? But it is maintained by largely the group that is employed by the iRODS Consortium, which is a paper organization inside of the Renaissance Computing Institute, RINCI, at UNC Chapel Hill. The member organization part here is that we try to pay our own bills by having people who depend on iRODS join and get a voice in the roadmap and have access to the developers, and obviously lots and lots of support conversations about configuration and optimization and things like that. So we do provide the development itself as well as support and training. And of course, if there's something custom or contract services that are needed, we do that too. Next slide, please. So that third point about the rule engine is the thing that we're going to lean into today, and kind of what it provides and what it affords to different organizations that want to do this. So the rule engine itself is a way to, you can consider it as a way to harden or formalize an organization's policy that may already exist. We assume that policy is a thing that smart people make up when they have a meeting. The people who are in charge go have a meeting and they decide what the policy is for an organization. We should have 3 copies. We should delete things when somebody leaves. We should make sure that administrators always have access to X, Y, and Z. Maybe this data can't leave Germany. This data is not allowed to be put on a certain machine that's in the DMZ or something like that. Whatever these types of policies are, security related or organizational related or compliance related, you can turn them into machine actionable code. A lot of that stuff can be automated if you know what you're doing and if the machine allows you to do that and if it's afforded to you. So the iRODS rule language, Python and or C++ can be used to write these rules, and they can talk to each other in the system. And the types of things that we mean when we talk about policy in the iRODS world are these sets of bulleted items here. This mostly about where the data is, whether we can verify it is the same data that we put there before. which computer it's on, which storage technology it's on, whether the checksums are good, and then of course a bunch of stuff about the metadata itself. You can extract metadata from certain file formats. You can associate it from other databases. You can make sure that it matches certain templates or predefined requirements. And then, of course, always looking at making sure that the things that are in the catalog are consistent with the things that are in the vault on various technologies. And so, stitching these types of building blocks together, you can build very interesting and compelling and sophisticated compliance engines, basically. And of course, obviously, iRODS can also reach out to external stuff. So if you have other systems that this might want to talk to or bounce ideas off of or use to authenticate, those kinds of things. This is all possible. This is effectively a programming environment or a programmable file system. And with that, you can write cool things to do stuff. So I'm going to hand it over to, well, Marco, I guess, is going to introduce the next three speakers, and they're going to tell you about the cool stuff.
Exactly. One question before we're switching over, Terrell, because maybe that's a good question as well, because how efficient is actually this file system embedded into an HPC AI mixed environment in a cluster? Because you actually selected your
Yeah.
program languages, and I think that was a smart move. Maybe you could highlight that a little bit more closer. That's maybe interesting for the audience as well.
Sure. So efficient is a loaded term. Some people mean just throughput. They want to know how fast things can move across a network. Other people want to know about I/O and, parallel numbers of files that can be operated on at the same time, things like that. We don't focus on that as much. iRODS is pretty efficient. It can fill a pipe. It can do things in parallel. We can spread things out across multiple machines. I would say that the right way to think about this, the most effective way to think about this as a new entrant, is that iRODS can be considered an orchestrator and to be considered the bookkeeping for these other potentially disparate systems. So while iRODS can do things in parallel, that's not its design goal. It's not optimized for those kinds of things. It does have a single database. We lean heavily on the transactionality of a relational database to provide the guarantees around order of operations and making sure that things happen in the designated order. This is not an eventually consistent system. This is not built on Mongo. This is not an async-based system. A lot of the massively parallel systems have a lot of pipelining with asynchronous things, and that's how they get the parallelism because they don't have to coordinate. They're completely stateless. iRODS is not quite stateless in that regard, but it is efficient if you use it for the things that it should be. And then if there is work that can be done asynchronously in your system, if you are allowed to calculate your checksums in the background, if you are allowed to move your data around and stage it overnight for the next day, for the next science run, do it that way. Set it up and let it run in the background and let the stuff that has to happen synchronously be the part where your users interact with it. So maybe that answers your question.
Absolute. Thank you very much, because I think that's a very important part. Once you're actually enabling the rules to your infrastructure and migrating data by rules, it will affect the network as well, and then that could interfere production. So thank you very much for that good input.
Of course.
Right. Okay. Thank you. I think then we are moving slowly to the next slide, please. All right. Yeah, here we go now. I think we are starting now with Lazlo Westerhof from University Utrecht. Lazlo runs an environment around about 5 petabyte of data for research data management. And yeah, he underpinned this by iRODS. Yeah, Lazlo will share how they actually address these compliance challenges and focusing on the making of this findable, accessible, and interoperable and reusable infrastructures based on rules and metadata. Lazlo, we are eager to hear your insights. and maybe we can switch to the next slide, and then Nirav is on the run, and then John Constable. Thank you.
Thank you, Marco.
Stage is yours.
Yeah, thanks. I'm Lazlo. I'm part of the Research and Data Management Services Department at Utrecht University, where I've been working with iRODS for the past 8 years. Utrecht University is one of the largest universities in the Netherlands, with over 9,000 staff members and more than 40,000 students. Our implementation of our implementation of iRODS is known as YODA. It's a system designed to preserve, share, archive, and publish research data throughout various stages of the research lifecycle. So with YODA, researchers can effectively organize their research data in alignment with the FAIR principles. So they can ensure that their data is findable, accessible, interoperable, and reusable. YODA is an institutional service that has been developed and maintained by Utrecht University since 2015. It's an important strategic development for achieving our research data management goals. And as an open source software solution, YODA has received sustained funding from the university's board, facilitated through the corporate services, and a national consortium dedicated to supporting its development. And currently, we have thousands of researchers and students at Utrecht University and other partners working on the system, and they have stored around 5 petabytes of research data in 9 iRODS zones. Next slide, please. So at Utrecht University, one of the primary compliance challenges we face is ensuring that the research data is both accessible and durable across multiple locations. Additionally, maintaining interoperability and discoverability of the research data through proper metadata management is crucial for compliance with the FAIR principles. So iRODS is effectively addressing these challenges through several key features. The first one is that iRODS ensures that the data is replicated asynchronously. This ensures that the data availability and durability across multiple storage locations is handled, protecting against data loss and enhancing the accessibility for our researchers. And iRODS also ensures schema-compliant metadata. And for this, we use custom Python rules and policies. With these custom rules and policies we developed, it automatically validates metadata against established schemas, facilitating interoperability and discoverability of the research data. This ensures that the data can be easily understood and utilized by others in the scientific community, even by other computer systems. With iRODS, we have built automated workflows for data archiving and data publishing. And this is streamlining the data management process through metadata-driven automation. And it also reduces the manual effort and minimizes errors in data handling, allowing researchers to manage their data more efficiently. So with these user-friendly workflows for researchers, iRODS simplifies the creation of FAIR-compliant data packages, empowering the researchers to focus on their core research activities. So as a result of implementing iRODS, researchers and students at Utrecht University can effectively manage their research data in alignment with the FAIR principles. This not only ensures that their research outputs are fair, but also allows them to focus more on their research activities rather than the complexities of data management, which ultimately enhances the impact and reach of their work.
Great stuff. That's great stuff. Lazlo, thank you very much for this illustration. That's really showing us how to implement these principles at scale. And what I really appreciate is that also you're sharing as open source this in GitHub this YODA deployment. That's really fantastic. One question is how you actually enabled this. Did you have actually external help, or was this mainly driven through your organization and institute?
Yeah, this started around 2015, where a couple of people were experimenting with iRODS, and over the years, we build up all the knowledge about iRODS, and so we currently have quite a large team of 8 developers that are all working on iRODS. So it's all developed in-house.
Wow. Okay. And how long did it took until it was in production?
From the first, so I think from the first development until the first publication done through the system, that took around 2 years.
Wow. Okay. But it's a massive thing. I mean, it's 5 petabyte, and you have to have a plan. Thank you.
Yeah.
Lazlo, thank you so much again. Now I think next journey will go over to University Arizona. So next slide is already here. Mirav Merchant, thank you very much for being here. Mirav is at the front of the implementing iRODS solution in a very unique and demanding research data governance requirements. He's deeply involved with Cybers, a massive open science workspace supporting over 125,000 users on 7 petabytes across several disciplines of astronomy, zoology. Sorry, please excuse my English. The stage is yours. Maybe you can give us more insights how you actually been using iRODS for compliance topics in your environment.
Thank you, Marco, for having me. And I'll give you a quick journey of when we started and where we are. So the driving force for us to adopt iRODS now, almost approaching 18 years, is the vendors were constantly swapping infrastructure and hardware on us, and it was becoming nearly impossible to afford a monolithic storage system on an academic funding cycle. And so we wanted an abstraction away from what was the storage and what was the science question and where the analysis was done. And iRODS, as Terrell pointed out, gave you that virtualization and allowed you to abstract where your data was, how many copies were there. And so in our case, a lot of our work, the heavy computing, was happening at a bigger computing system at my colleagues at TAC, Texas Advanced Computing Center. A lot of the quick, short-running jobs were running at that point in Condor from University of Wisconsin-Madison, from Miron's group. And then we had unmet needs on the cloud space, where in those days we were using Eucalyptus, which then we morphed over to OpenStack. And so we had to manage data that was needed in so many different venues. And we had prolific data generators like our telescopes, which University of Arizona is a very large astronomy department, and they're very prolific. And so we have systems in Chile, or the Event Horizon Telescope, which is like the first images of the black hole. So we always are working with many petabytes of data, and usually it's spread globally because the work is done in Germany, some in Austria, and then the final analysis is happening in Tucson or in TAC. And so keeping track of where things are with a single vendor solution was just not feasible. The technology was not there, or the price point was not there. And so we decided that the policies and rules are what we wanted to control. The provisioning and providing of storage, we wanted to, the vendors or providers of that data, and the cloud providers were still very early in those days, but now we span that very nicely. And so we don't care where the physical storage is happening and how that is managed, but the bookkeeping of what is where comes from iRODS. The policies are no longer tied into some monstrosity that a cloud vendor says, use my function or my style of metadata and move everything into my platform. We wanted that abstraction, which we have. So iRODS has been phenomenally important in our growth over the last 2 decades, and I see it continue in the future. So Cyverse was born through NSF funding because National Science Foundation, which is our primary funder for science things, said that we are spending a lot of money giving the university some of the fastest networks, and our computer scientists and others are building some of the best algorithms, and then we are providing expensive HPC systems, but the biologists are not using it. And how can we change that? And so they put out a call for the next generation of cyber infrastructure for plant sciences. But Cyverse was born as a project, as I planned, and in 2008. And then we said, we are not going to reinvent the wheel or create yet another piece of software that will die once the grant is over. We went to different communities and learned what they were doing. And we learned about iRODS from our astronomers in those days. But then we went to the high throughput computing community, went to the HPC community, and then we decided to write the middleware that was missing to make it user friendly, make it easy for organizations to manage. And so that was the birth of iPlant, and then it's kept on growing. So we've been very fortunate. And today I have AI institutes where our data is managed through this. We are even building foundation models funded through NSF and NVIDIA as part of NAIR, and all of that data flows through our iROD systems, and it goes to whoever is providing us the GPU. Now, many of you who may not be from academia may be surprised that why are we trying to distribute this, but we are very opportunistic and poor at the same time. So whoever gives us GPUs, we show up with our data. You tell me we can do something for 1 week. Within few hours, as Terrell said, we can stuff up a pipe and move hundreds of gigs or terabytes of data, and then we start using those resources. So we are very efficient because the movement of data then the orchestration becomes really easy. As a project, we've been really active. So some of the early Python work came from my students and is now adopted by the consortium. And the consortium model is really helpful because I get funded to do bleeding edge stuff, but when it's stable and it's working, we want it to be widely distributed, and we don't have that expertise or ability, and that's where Terrell and his team come in. And obviously we have to make it at a standard where the consortium is willing to adopt it, but it's always been a very successful collaboration. Similarly, the Go client, and so a lot of our work has over the years moved into Go, and we have a lot of tooling for Go, which I think many other groups are also using, and we support it. Similarly, Kubernetes became a mainstay in our computing platforms, so we developed CSI drivers for it. And those of you who will be coming for our consortium iRODS user group meeting will also get to see the MCP, the model context for iRODS, so the LLM and agents can talk to iRODS, and we are starting to use that for many of our projects. So last thing I would say for this slide is iROD plays a very critical role in integrating our on-prem and cloud, AWS primarily, but we also have cloud resources where we don't have a choice. We are going to get the grant saying this data is in GCP, go use it. And I cannot say, oh, let's move everything to Amazon and then work with it. So iRODS has allowed us where in GCP, we say behave like S3. And next thing we know, that data is visible and controlled through the policies we have. Next slide, please. So specifically today, I want to talk to you about how we meet compliance for some of our very specific projects. Cyverse is used both in health and also in defense. So today I'll talk more about health because that's easier than defense for various reasons. So HIPAA is a standard within the US that we have to follow where we have health information, so PHI being personal health information and personal identified information. And so collaborating with a lot of our hospitals that send us data, we had to give a lot of strong guarantees. And some of you may be surprised to know the hospital earlier would only care about the pipeline and say, oh, you're SFTPing, it's secure, the S, good. Here's the data. Now they're like, how many people touched it? When did they touch it? Are you going to delete it the day the IRB is over? What's the guarantee that it was deleted? So things over the last 5 years have become more and more, especially after the pandemic. A lot of our hospitals became even more aware that they have to share, but they have no control once the data leaves their environment. And so iRODS became a very nice way to show them how we give access, who has access, what's the audit trail. And even if the data was in Amazon and some on-prem, and some of you may wonder why we do Amazon and on-prem, there are some things that we can afford to do more economically in Amazon, but a GPU cluster in Amazon will bankrupt me very quickly, the way the students work. And so we have to sort of find the middle ground. So there is some data that sits in Tucson and some that sits in Amazon, but it's all one unit to our users. So we run a lot in Amazon Gov. And then iRODS provides, we have rules and policies and metadata that is very, very detailed, and how we take permissions, give permissions, hide. Even the metadata is not just available to everyone. And we use metadata to do many, many things, including the bookkeeping of who is consuming how much, and when do we need to prevent somebody from doing something. We developed a lot of the SFTP integration into iRODS because we needed that to keep our hospitals happy. But at the same time, we had a lot of devices that were sending data. So we had to think of a public-private key type of infrastructure, which works, as I mentioned earlier, the Kubernetes driver. So if data is shared, it's visible to the person in their Docker container that's running in our Kubernetes environment. We have a very nice workbench that's created where we can say this person can connect to this data set and this database that's somewhere else, all as a very nicely integrated Kubernetes launch. And then they can do their analysis, could be a Jupyter Notebook, could be our Studio, or a virtual desktop. And while they're doing analysis, they can increase or decrease their time and say, oh, I need more time to finish this, and it'll let them run. And if they've run out of credits that they have internally, which is like our funny money, which we give to each of the users based on their subscription level or permission level. And so that's worked out really well. You can read what's in Soteria, which is sort of our analysis enclave. So we create many enclaves, and they come as infrastructure as code, and iRODS is installed as part of our infrastructure as code. So that's sort of a quick overview of how we do the HIPAA compliance.
Yeah, thank you very much. That's really, really deep insights of it, because what my takeaway is here, number one, it's a very budget-driven world in your environment. You're covering actually, to be honest, I think worldwide compliance topics in one environment. And you're also using AWS on a budget. So that's very, very interesting. And especially now you're treating here data very, very important, and patient data are really restricted, and you have to give reports. And I think that's also valuable for all organizations in academia and in industry. So I think you agree on this.
Yeah. And Marco, one part I forgot to mention, it's still not in production, but many of the hospitals have moved to, platforms like Databricks or Snowflake. And they, at the heart, they have Parquet and Iceberg as sort of, they'll have some connection into the Delta Lake or some way to get data. So we are also going to use that to expose what is shared with us into iRODS. But right now, it's very early, but that is on our roadmap. And I feel that's going to be the future for us, because a lot of the hospitals are getting reluctant to transfer the data over. So they want to have us peek into the data lake where they've given us permission, and this will make it easy for our existing users where they don't have to learn the vagaries of that platform, but they can still see the data. And so we are also integrating that, but that's more future work.
Right. One question, or final question now before we switching to the next slides. Did you actually check on the market what kind of tools are there available and why you selected an open source solution?
Good question, Marco. So we've always kept our eyes, and a lot of my early funding came from IBM and others where we were co-developing products. So we are very friendly to industry, but what we were finding is something that had a 5-10 year horizon and was affordable without too much engineering cost. None of the vendors had that in mind because there was so much flux in the market, and policy and metadata was not a primary component. And then fast forward 5-10 years of us using this, if somebody comes along and says, oh, here's the Delta Lake, bring it in, we are able to do that. And so that open source nature of this allowed us to keep pivoting to whoever was the provider of that capability. So unfortunately, because we didn't find a long-term partner that was interested in the virtualization layer that was vendor agnostic, iRODS was a very natural fit for us. So hopefully that answers your question.
Yeah, absolutely. Thank you so much. All right, then yeah, let's jump to the next participant and Sanger Institute. John, you're running also lots of data, 26 petabytes in genomic sequencing. And I do believe you are having similar requirements like Nirav with the hospital part, because that's actually covering a lot of other things where you're actually managing disease genomics, engineering genomics, and planetary genomics, and it's producing a lot of data. Yeah, please give us an insight how you guys are managing compliance topics in your environments. And yeah, you're using it since 20 years. So that's long-term long-term knowledge. Please give us some insights, John. Thank you.
Thank you, Marco. Hi, folks. I'm John Constable. I'm working at the Wellcome Sanger Institute. For people who don't know us, we were part of the early effort to sequence the human genome. That's kind of our original claim to fame. And as part of that, we had to basically get the data out and out the door as quickly as possible to try and be part of that. And I think we ended up 1/3, I think, of the human genome at the time, sequencing in the end. So a lot of our background has been in genome sequencing, and genomic sequences change a lot over the years. New technologies come, but the main thing that comes with all of this, of course, is more data. It becomes cheaper and cheaper to sequence genomic data, and so our researchers get more and more bang for their budget when they go and sequence data, which means we get a lot more data that we end up storing. So something that may not be as obvious from this is that, yes, we've been using iRODS since for 20 years or so, but we've got 20 years worth of data in there, going back, formats and instruments and all those kinds of things. And it's interesting when Noaf was saying that they were looking for things moving between it. When we originally brought iRODS in, one of the reasons we brought iRODS in is we'd already tried it 3 times ourselves by writing our own version. And a bit like the old Monty Python sketch, by the 4th time the solution had fallen over, we decided we better go out and look what other people are doing. And that's how we ended up with iRODS. One of the main things with the iRODS that appealed to us initially was the idea that we weren't locked into it. The fact that we can have underlying file systems that hold the data and the metadata and the information about where all this is kept in a database that you can independently query if you need to, means that if something goes terribly wrong, we could reconstruct the database from the data. I go the other way, but you get the kind of idea, and it gives us a lot more flexibility and a lot more movability, which I'll talk about a little bit later on. So these days, although we were Sanger has been known originally for kind of doing sequencing, and in fact, I think don't know if we still do, but at one point we had the largest genomic sequences in outside of the US in non-government hands, I think, something like that. And we ended up doing something like a third of genomic sequencing in for COVID in the pandemic. And so that was quite an adventure supporting all of that. But that isn't the whole nature of Sanger, of course. Because we've got people coming who understand that kind of genomic thing. We've been expanding out from there. What does that mean? Once you've got this data, what can you do with it? Where does it go? That kind of a thing. That's really how we've been trying to support our scientists and researchers across all of that, really. And as I'm on the slide there, we've used iRODS and we've upgraded it regularly through the years. I've lost count how many upgrades we've done now. I know I've done 6 personally, but there's been more than that done over the years. And this is a consistent. We've got one zone, as it were, one federated area of iRODS that's been running for that entire 20 years. Upgraded kind of a thing. And in fact, we've used this kind of data virtualization, storage virtualization that Terrell was talking about earlier to actually migrate storage platforms effectively under our users' feet. We've moved at least 3 different vendors, 2 different kinds of technology. We've moved off things, around things. We've moved entire data centers. And all of this we've been able to do by effectively telling these when they come in, I know you want to go and get your data, but don't go and get that copy. Go and get this copy instead. And then we pick up that data and literally drive it down the motorway, put it in a new data center, turn it back on again, and the users will none the wiser. And that kind of flexibility and it's saved us in all kinds of ways. Costs as much as anything else. Next slides, please. So what we use iRODS for is kind of, as Terrell was saying, kind of an intelligent file system, really. And there's a number of rules that we've got with that allows us to kind of give the guarantees that people need for it. So one thing that we have, first of all, is that anytime we say to the scientists, when you're uploading data, there's particular things you want to put in, metadata, for example, or you generate a checksum of the file when it's uploaded, so that when it's downloaded, they can trust that it's the same data they got back that they gave us. But we don't just rely on them doing that. We enforce that to make sure that even if they forget to do that, there's still checksums generated, which means it can still be checked later on. Also, one of the requirements we had from our funders was that we had one of the copies, because we have 2 copies of most of the data in iRODS, was held outside of our main data center. So if something happened to it, then we would have another copy of this. And again, rather than relying on vendor solutions to do this that change over time and you need to support kind of different ways. We've been using iRODS to do this instead, which means that we can use different vendors, different platforms, sometimes one platform that works very well in one kind of data center and a different platform that works better in a different kind of data center. And that is completely opaque to the end user. They just know that they go and get their data or upload the data. And that having this completely automatically done means that we don't need to worry, has the data been copied up? As soon as the user has uploaded the data, that data is in both places. And that means that we can, as I mentioned earlier, we can play around with where the user gets the data from for the most optimum performance. Our compute clusters, so you can say when you're downloading data for use on the compute cluster, use the most local form of the storage, for example. Then, as I mentioned, we use metadata. A lot of the reason the scientists use iRODS is that they're able to find their data there. And anyone who's worked in the wider scientific community knows that you get quite a lot of files sometimes that are named things like my PhD thesis _final v3 _final. And so instead of that, you can actually use metadata tagging and things like that so that people can track exactly where things are. And what this happens from a practical point of view is that when our sequences generate data, it gets tagged with particular users that can see it, things like which sequences and reagents we used, all that kind of information, and it gets pushed into iRODS with all of that metadata. And then the users are told your sequencing is finished, QA, all that kind of stuff is done, and they can go into iRODS, they can query iRODS and say, right, what data have I got access to? What's the new stuff that I've got? What's the data that relates to this particular study? And and then they can stage that if they need to. They can, in some cases, work on it directly and kind of work around there. We've also been able to use, I think, an earlier slide telling me about storage tiering. We've been able to do things like where we send some of our data to the European Genome Archive, called the EGA. We say, well, we don't need to hold as many copies of that. So once that's confirmed that's been uploaded, we then drop down to only one copy of it. And those kind of more strategic tiering decisions you can start making when you're able to set rules on these kinds of things. Likewise, we have quotas, reporting on the quotas, so we can tell particular areas what space they're using. That can then be used for reporting back, so people can do kind of like show back and able to say to people, we're using this much data, we use this much data over the time, therefore, next year we're expecting to use this much data, so we want to have a little bit more, and you can have that robust discussion of, well, last year you asked for a petabyte, and actually you've only used half a petabyte, and all those kinds of cut and thrust of internal policy. Also, the thing that really helps us is having a single login. I mentioned we've got a zone. We've actually got, I think, 5 zones, iRODS, and requiring our users to remember different logins to each one of these and have to log into one and then across to the other and all the rest would be quite the ask, I think, when they've got other things to be getting on with. So it's really helpful to have one single place where they sign on to the clusters, they can connect to iRODS, and they're using the same credentials across these kinds of things. It makes it easier from a cybersecurity point of view as well. If when the user leaves, moves to a different institute, when we have to disable their account, we know that it's also disabled in iRODS, and there's no chance of data leakage that way. Those kind of access control and access control list kind of things. Mentioning about the MD5 something else that people might know about storing large quantities of data, particularly in the terabyte, petabyte stage of stuff. Although storage systems these days are very reliable, and they're less reliable when I started, but these days, pretty reliable. But nonetheless, things can go wrong, data can get corrupted at rest. How do you know that's the case? How do you check that's the case across petabytes worth of data? And iRODS has a lot of tools that allow us to do that kind of thing. We have things that, for example, check on a monthly basis, group of files, are the checks on the same if the file that's on disk, the ones that are registered in the catalog, are the ones in the catalog present on disk, and all that kind of like sense checking and sanity checking that allows people the peace of mind of operating the things.
Right.
I think that's me.
Yeah, wow, that's really fantastic. And seeing that you're using it since a while. Yeah. How if a problem occurs, if you need and require a patch, how are you communicating this with Terrell? Is this working very well for you guys? Because that needs to be mapped, because you guys are changing a lot of such a size cluster. So it might be maybe a challenge, but how is this discovered for you, and how you can communicate this with Terrell? I guess that's
so we're part of the iRODS Consortium, which
all
is
right.
The wider group of people that use iRODS and contribute both money to the consortium, but also time and in some cases, in this case, code and things like that. So we have kind of this arrangement where we have regular support calls, and we use the open source side of things. We're regularly raising tickets. We've seen this, is meant to do that, we'd like it to do this, all those kinds of things, which allows a very open communication with these kinds of things. I think that we've had an issue where when we did an upgrade, for example, I think 417, I think something like that, where we had an upgrade, we found an issue. Renzi and the team worked really responsive back and forth trying to sort out what the problem was, and we got a new release actually worked out, I think, within weeks when we actually found the issue. Now, Terrell, don't worry, I don't think I'm promising that for everybody all the time, but I think the issue we'd found was going to be causing enough issues that we're able to kind of do that. But having that close relationship with both the people developing it, but also the wider community. I know most of the people on the call today, for example. We meet up at the user group meetings where we send stories, war stories, and that kind of thing. And it's a close and supportive community, which is really helpful when you're doing this kind of thing.
Great stuff. Thank you very much for these insights. That's very important. Okay, next slide, please. I think we're going to open up the panel. We are actually expanding a little bit the time. It was a plan to having an hour, But I think it's also now up to the attendees. Gentlemen, ladies, please drop your questions to these experts. I think the takeaway is quite impressive what we've seen in different areas and with different requirements, with different compliance directions and requirements. So I open up the channel. We do have a couple of questions in our chat here. Maybe I start with Terrell, and you could maybe jump on one or two questions and answer these questions, and we're kicking them off then other questions.
Sure. So we've got 3, 4 that have already been answered in the Q&A, but we can say them out loud as well.
Mhm.
We've got a question around how do we implement restrictions when you don't want to share something with a foreign country or foreign country of concern or people in a certain
That's a
district
good
or
one.
domain. And so my answer in the chat, and I think these are visible to everyone. Please let me know if they're not. So iRODS obviously has its own users and groups and ACLs, and all that would work as you would expect. But in addition to that, iRODS can limit network activity based on network ranges and that kind of stuff. And of course, in the end, the rules can always make decisions with any number of inputs. So if if you only wanted to allow certain connections from certain people on certain days, you know, you have a programmable environment, so that is possible. So those types of restrictions can be done. Out of the box, we have kind of the normal things that you would expect, but I think our superpower is the fact that you can go in and have more opinions with a little bit more code. Every operation in iRODS has what we call a policy enforcement point. And so every operation that iRODS can do between opening and reading and writing and saving and checking and going to the database, all those things can have pre and post code that can be administrator or user supplied, which of course gives it a full capability to do things. Another question about the languages that we support. So I mentioned the iRODS rule language, which is its own thing. It's kind of C style. That was the original one. iRODS is we didn't say this. iRODS is a plugin architecture. So there are 6 or 7 different plugin interfaces for iRODS, including the database, the network, the storage flavor, as well as the plugin, the rule engine plugins. And so the 3 that I mentioned, iRODS rule language, Python, and C++, those are the 3 that we currently support as a plugin. But if somebody wanted to write one in Go, if someone wanted to write one in JavaScript, if someone, pick a language, those are possible. They haven't really made sense. We haven't really heard that from the community, but if there is a demand, my job, like John was saying, is to field questions and field support. But if I see 2, 3, 4 people developing the same thing or seeming to request the same style of solution, my job is to throw up my hands and say, whoa, let's stop. Let's do this in one place so that it solves it for everyone, because, that's going to be better.
Right.
I will skip the Yoda question for now.
Yes, I think we
Lazlo.
also, the
And then
questions
there's a
we can't
Soteria
answer.
question.
Exactly. What we can't answer today, we are actually answering this and after with the survey. But yeah, one more question is
May
actually.
I answer the metadata system
Please,
question? So
yeah.
we also have working groups in the consortium, and we've got 3 or 4 that over the years, one for S3, one for metadata, one for some other things. We have recently produced, after 6, 7 years of thinking about it and talking about it and trying things, a metadata template system. So iRODS provides the verbs for attaching and detaching schemas to collections and data objects, as well as the verbs, the functionality for gathering all the ones that are related to a particular data object or collection. And then the most important one, the validate function, which basically means it takes the metadata associated with something and all of the schemas that are associated with that same thing, and it runs it through the validation and produces a thumbs up, thumbs down. And that type of looping and kind of building block mentality is what's allowed, like I think Lazlo was talking about, all the schema validation that they do. Those kinds of things, we provide the building blocks, and what you do with it is up to the implementer. Those are based on attribute value units. You don't have to use the unit in iRODS, so it can just be key value if that's what you're familiar with. And the schema system, the templating system, is all based on JSON schema. So I think that answers the question in the chat. I'll pass it back to Marco.
I think one more to go, and then we are jumping to the next slide. So question goes actually to Lazlo. So what sort of use cases has Yoda supported? Where are any data streams limited, observed in the concurrent uploads and downloads? Could you give us some insights on this question? Do you have an answer?
Yeah. Yoda originally started as a project for one research, a very big research project, and along the way it spread out through the university. It's now used by almost all faculties in the university, and our use cases range from storing questionnaires from students to storing video data of behavioral analysis of chickens. So we have a very broad spectrum of data that's being used, where the generic use cases between all those different faculties are archiving data as a data package for long-time storage and publishing data packages to be shared with the world. Data stream limits. So we have observed limits, but most of those limits were limitation in our infrastructure. For example, when we have been doing tests where we were exchanging large amounts of data between the university and the medical hospital, and with iRODS we could easily fill up the complete pipe between both institutes. Are there any cases that interfere with HPC and cloud infrastructure? Yeah. Even our national HPC environment does have the I commands available. So people that use the HPC can directly connect to Yoda using the I commands from the HPC environments. I think that kind of sums it up.
Thank you so much. Yeah, I have a final question, which goes actually to Terrell. Terrell, what's actually the limitations on the iRODS? Can you run it on is there a number of iNodes restrictions? Can it run on an exascale system?
Yeah, so we do our training on a single VM. Obviously, that's not a production level system. We've got demos and things that run on laptops, but that's just to demonstrate the abstractions and the fact that just to give people a chance to play with the vocabulary and the types of world building that we can allow. But yes, it definitely runs on systems with tens, if not hundreds of servers. I think John has more than 200 iROD servers running at the same time. I will say that if you are of an architectural bent and you're asking this question, so iROD still, like I said, leans heavily on the transactionality of the database. The database plugin architecture allows you to pick your database. We have support for Postgres, MySQL MariaDB, and then we still ship an Oracle plugin. I don't know that anyone's using that anymore. If there is another database flavor that you like, that's a possibility for us to look into if there's something that you need. If you need a clustered database and you want to have a system that's kind of everywhere, then right now we leave that as an exercise to the administrator. We assume that grown-ups are running databases in a grown-up way. iRODS just connects to it with ODBC. So if you've got 50 servers and you want them all to have access to the database, and that needs to be a shared clustered database, then we provide the tools for that, but we don't necessarily test it that way ourselves.
Yeah.
I will.
Environment you have available.
Yeah.
Thank you so much. So I think we're closing the roundtable, number one on time, but maybe there's another round where we're diving into other topics. So next slide, please. Tara, that's up to you now.
Yes, thank you. So if this is interesting to you, this is just a teaser. We have 2 more days of this soon. If you want to be virtual, you are more than welcome to come to Durham, North Carolina for our the day of training and a day of troubleshooting. That's the 17th and the 20th. But the 18th and 19th, we will have 2 days of virtual talks. Some of us will be in person, some of us will be virtual. This is the 17th annual user group meeting. I guess you can't click on it if it's a Zoom meeting, but if you can probably memorize that one and type it in all by yourself and get to that link. Registration is still open. Please join us. You can also, if you chop off the 2025 on that URL, you can see the last 16 years and click on the past talks. All these things will be recorded and available afterwards. But please join us if this is compelling. Lots of people talking about their use cases, as well as lots of us talking about what we're working on and what the future will bring in terms of iRODS development itself.
Way to go. Yeah. Next slide, please. So I think next steps, as a teaser, that was just definitely a series of several deep dives technical into it. Terrell and I've been thinking about it, to diving into the world HPC and AI and how actually how to migrate efficiently data for AI and large language models. Could be a one, but we are actually sharing this with you because you guys are driving this in future. So we will send out a survey on this, and yeah, touch base is of course iRODS resources. Duet now is the European partner of iRODS, so we willing to exhibit next week on ISC in Hamburg. So if you're around in Hamburg, then please step by. We have a couple of swags and interesting giveaways from iRODS on our booth. And yeah, next forum, again, we are diving here into HPC AI and large language models with CPU and GPU workflows. We're thinking about it, but we will do also a little survey. So you're driving the next session, maybe around July or something like that. I want to say thank you to everybody. Thank you very much for taking time, sharing these insights. I think it was very, very valuable. As I see now, we have still 29 people in the call, no 27. We actually addressed an interesting and not boring topic. I enjoyed it much. So thank you very much again. Thank you very much for the mouse behind who's switching here the slides and manage the Zoom thing for us. And yeah, we are closing the call. I wish you a fantastic day. I'm heading up now to the next meeting, and thank you very much for this time, and see you next time in Hamburg or in the user group meeting or in July. Goodbye.
Bye-bye.
Thank you, everybody.
Thank you.
Thank you.
Cheers.